Drones have changed the tactics of war forever. They are an integral part of combat operations. Drones are used for round-the-clock and all-weather intelligence, surveillance, and to strike the enemy on the battlefield, and to destroy objects and equipment deep in enemy territory. Now, FPV drones carry out up to 80% to strikes during the war in Ukraine, and their effectiveness is comparable to artillery systems. The importance of drones is increasing due to the lack of the required number of artillery systems and ammunition. The cost of one FPV drone ranges from $600 to $1,500, while the price of a 155 millimeters projectile has reached $8,000. Considering the role of drones in war, the leadership of the armed forces of Ukraine decided to create a new type of troops, the unmanned systems forces. The first commander of the unmanned systems forces is Major Robert Brody. His military call sign is Madhyar. The photo also shows the best commanders of the UAV units of Ukrainian army. Drones are also actually used in secret operations of the Ukrainian Special Forces, the main intelligence directorate and the security service. Many of these drones use computer vision systems based on artificial intelligence. This video This video shows the MID operation to destroy Russian air defense systems on the Crimean Peninsula. The enemy's radar systems were destroyed. This video shows, This video shows the results of a special operation by the MID unit Primary, in English, Ghosts, to destroy the S-400 air defense system in Crimea. Radar stations and launchers, they are destroyed. In addition to aerial drones, Magura sea drones also participate in MID operations, attacking not only ships of the Russian Black Sea Fleet, but also helicopters and aircrafts. This video shows the work of the 13th MID unit to destroy an aircraft with a sea drone. The most famous secret operation involving drones was carried out on June 1st, 2025 by the Security Service of Ukraine. On this day, 5 strategic airfields of Russia were attacked simultaneously: Alenia, Belaya, Дягилево, Ivanovo, and Voskresensk. The Belaya airfield is located 1970 kilometers from Ukraine. The strikes were carried out from Russian territory. The operation was prepared for a year and a half and was led by the head of the Security Service of Ukraine, General Maluk. President Zelensky knew about the preparations of this operation. "117 drones were brought to Russia, assembled and hidden in the roofs of summer cottages. The production of these cottages was organized in one of these regional centers of Russia, not far from the building of the Federal Security Service of Russia. At the appointed time, the houses with drones were delivered to the parking lots near to the airfields. The roofs of the houses were automatically dropped, and the drones began the attack. A total of 41 aircraft were destroyed or significantly damaged, including 34 strategic missile carriers that are capable to carrying nuclear warheads and that Russia uses to launch cruise missiles at Ukraine. This is 34 of Russia's strategic aviation, worth more than $7 billion. Russia will no longer be able to restore these aircraft because they are no longer being produced. This is one of the most successful and significant intelligence operations in the world. This video shows footage from an onboard camera of one of the drones involved in the attack on the Belaya airfield. The drone takes off from the roof of a small house and fly towards the airfield. This drone is controlled by an operator via a mobile phone system. Another unique operation of the Security Service of Ukraine was the operation to destroy the air defense system in Crimea on July 2nd, 2025. The uniqueness of this operation was that the aerial drones were launched from a sea drone that approached the coast of Crimea. The drones were equipped with an AI-based cadence system. As a result of the attack, the Nebo-M radar system worth more than $100 million was destroyed. However, a new phase of drone warfare is now beginning. There are fully autonomous drones that are capable of navigating and striking targets deep inside enemy territory using onboard AI systems. There are known combat uses of such drones by Russia. This is the VU-2 drone, which is shown in this slide. You can see also the main characteristics of this drone. Similar AI systems can also be installed on Russian attack drones such as Shahed and Zala. Ukrainian military companies are also producing similar AI-based systems. This video shows the combat use of the TFL1 system from the Fourth Law Company.
Quick question. This particular clip, does it show the AI-operated drone or a people?
Yes, yes, yes. Yes, of course. Our company, Advanced Cyber Machines, also designs similar autonomous strike systems based on AI. This video shows a drone testing an autonomous attack. The drone is launched by an operator, then autonomously detects targets, in this case a car, selects a specific target, locks onto it and attacks. The attack is aborted by the operator to prevent the drone and car from being destroyed. This slide shows the tasks that need to be solved when developing such a system. As you can see, this is a list of complex technical and technological problems, each of which is critical. They have set ourselves some challenging tasks that we are solving then designing our AI-based system. The list of these tasks is presented on this slide. The electronics architecture for our drones is standard. For UAV, these drones with computer vision system. The main computing unit for implementing the neural model and tracker algorithm is a companion computer based on the Orange Pi single board computer. However, the main innovative component of our development is the onboard computer software, a detector based on the YOLO neural network and a tracker and algorithm that captures and accompanies a target during an attack. The results of these algorithms are transmitted to the control algorithm autopilot companion, which calculates the displacement of the target center relative to the camera center and generates the necessary control signals to compensate for this displacement. Integration of the autopilot companion with a standard autopilot, such as ArduPilot, is carried out using the Mudlink protocol. This approach allows us to implement the following target selection scenarios. First, automatic target selection without operator confirmation. Second, semi-automatic with operator confirmation. And third, manual. The operator sets the target manually, and then the homing algorithm is triggered. Our system uses the YOLO neural network model. YOLO is an abbreviation of a series of neural network models. You only look once. The algorithm recognizes objects, samples of which are contained in the data set and detects them, then is localizes their spatial location. This localization is presented in the form of a bounding box, a frame around an object, indication with the classification accuracy. They expect our system to appear on the battlefield in Ukraine in the near future. That's all. Thank you for your attention. God bless America. Slava Ukraini. Thank you.
Are there any questions to the speaker? Yes, please. On your systems, how do you handle communications? Is it all a local operator locally to the system, the drone itself, or do you do any backhaul to a headquarters element or anything for control of the drone systems?
I don't have, maybe you.
So is the communication local, or is there a communication with some sort of center remote?
Yes. We have a few scenarios about using our drones in the battlefield. First scenario is we can use fully autonomously these drones, And second, the operator maybe controlled this drone.
Locally to the system, so within line of sight.
No, not locally. It's next step. We can hit targets deep in the Russia territory. But for this need,
Question is remote communication. How is the remote communication done when it is?
yes, without communication with operator, yes. They can use drone without communication of operator.
All right. Any other questions? Yes, please.
What is the precision of it? Like, how do we determine whether or not it's an actual target vehicle or a civilian vehicle? Like, what helps to give that boundary?
How do we make sure that the target is, let's say, a military target
Military
or
target.
a
Yes,
civilian
yes.
target?
Yes, it's very interesting question because they can teach our model for different targets, civil targets or military targets. Yes, but now in deep of enemy territory, all vehicles is our targets.
Other questions?
Is the drone being destroyed in the attack, or is it coming back to the operator?
Is it a suicide drone or not?
No, this is a drone kamikaze.
Other questions? Yes,
Yeah, I
please.
noticed in the AI-powered drone that it looked as though the operator, there was a fail-safe. In the event that the drone targeted a friendly, there was ability for the operator to change the target or cancel the mission. Is that what I saw? Is that correct?
Your question about how
So I think in the video it showed that the operator aborted the attack. Question is, when the drone is under AI control, is there still a possibility for the human operator to abort the mission?
yes, yes.
Sir, how many object classes are your models trained on? Do you have like one drone trained on like flying just into tanks, or are you training one drone to detect multiple object classes?
No, each drone may be attack different targets, not only one target. But operator can control this process. Or before attack, operator may be change different targets. For example, only tanks or only vehicles or all targets.
Any other questions?
Are you doing any anti-personnel testing?
Anti-personnel?
Uh,
The enemy soldiers?
yes, it's maybe, but these systems designed for long distance in deep enemy territory.
So why not personnel?
No, not because in close area of front, we used in Ukraine use FPV drones with operator for personnel.
One more question, maybe?
I have a question for you, sir. Can the AI drones that the Ukrainians are using, can they be used against the Russian drones that Russia is using? Or is it only for tanks, personnel? Can you use it for anti-drone warfare against the Russians? Drone on drone.
Yes, they have systems, anti-drones, not only anti-drones, it's systems anti-aircraft, maybe the use for other drones, air defense, like air defense system. And they have different solving of this problem. So yes, we have.
But the example that you showed specifically,
Yes.
can that be used against other drones?
Not these drones, not this, but other drones. My student in Kharkiv University developed this system now, and this is in Ukraine. It's like in United States students design project. Welcome.
Any other questions? Great. Let us thank the speaker again.
Thank you so much. Thank you.